Hello, good afternoon, everybody. My name is Gerhard Pretorius. I'm a cloud product specialist with Rackspace in Asia. And today we're going to be talking about autoscaling in the cloud. So a little bit about me before we start. I've been with Rackspace for about 10 years. I'm first in London and now in Hong Kong. And what I'm focused on is providing customers with support in how to use the Rackspace cloud effectively. And being with Rackspace for such a long time, I've firsthand been able to experience how cloud computing is changing the way that people think about hosting. And Autoscale is one of the really exciting concepts that have come about in the last couple of years due to cloud computing. So today we're going to talk a little bit more about it and also give you guys a demo on how it practically works on the Rackspace cloud. A few things before we start. As Eric has mentioned in the chat, please feel free to go ahead and ask as many questions as you guys want in the chat. If it's a question, a short question pertaining to anything specific that I'm discussing at that time, I will answer the question during the presentation. Otherwise, if it's a question with a little bit longer answer, we will park the question until the end of the webinar, and then we'll answer all your questions at the end. A couple more things. All the things that I'm going to be showing you here today, all the demos, we will send out an email to you guys with a step-by-step guide how to implement this yourself. So you don't have to go and scribble these things down madly or anything like that. You'll have a step-by-step guide in terms of how to set these things up, what we're going to do. Okay, so let's get started. So as I said, it's autoscaling in the cloud. A little bit a quick agenda. We're going to be covering obviously what is autoscale, how does it work, but then also the benefits of autoscale to you and your business, and then quickly cover some requirements for autoscale, and then the thing that I'm sure all of you are here to really see is how this practically works. So I'm not going to be talking for that long. We're going to be getting into the demo fairly quickly, and that'll be just a step-by-step guide on how to set this up, and then also show you guys how it practically works and how scaling can work. And then we'll roll back to some questions at the end. Right, so also just in terms of setting some expectations on the intended audience, we are going to be covering some technical concepts here today. So if you've got some understanding of public cloud services and some scripting knowledge, that'll help you out, but it's not required. Right, so let's get started with our first topic, and that is, what is autoscale? In a simple sense, autoscale is just a set of rules that you define that allows your cloud infrastructure to react to events that occur. Now, these can be events, that you set, that happens on a specific time. So it can be scheduled events. For instance, if you know that you are going, weekends are your busy period, you can set autoscale to trigger these scaling events, at a specific time, say on a Friday morning, and then, to scale up some infrastructure for you, and then on the Sunday afternoon or Sunday evening, scale that down for you. But it can also be in response to monitoring events. And that's what we're going to be demoing for you guys later, is to see how monitoring events that occur on your infrastructure can then actually trigger some scaling. So again, it's, in a very simple sense, it's just a set of rules that you define that a system will then look at, and based on events that occur, it will dynamically grow and shrink your infrastructure for you. So how does autoscale actually work then? Here's a graphic for you guys, which is a typical web application infrastructure that we see today. You've got your website users right at the top. They interface with your two web servers through a load balancer, and you've got your database server on as the back-end infrastructure. So the way that autoscale should work is, let's for argument's sake say you are experiencing a spike in your user load, right? So your traffic is going up unexpectedly, and you experience a condition on your web servers, right? So you experience a CPU condition on your web servers. They generate a CPU monitoring alert. What Autoscale then allows you to do is then, through a set of API calls, it will dynamically go and build some more web servers for you. And then as these web servers then come online, what it will also do is then integrate them back into the load balancer. So they will, your Autoscale system will add these servers into your load balancer for you so that they are integrated into your environment. And then as they come online and they're ready to accept work, the load balancer will then distribute more traffic to your web servers. So in this scenario, you can see that we have a condition that occurs on our infrastructure. We've got a high CPU alert that traditionally would have caused you either downtime or slow response on your environment. But using Autoscale, you can dynamically again add additional infrastructure, based on events that occur, so that your environment dynamically grows and that it can handle the load that it's being subjected to, and the reverse as well. As your usage then subsides and these monitoring alerts or these monitoring triggers then go down in CPU usage, then Autoscale can also trigger your servers to be removed again. So you're not paying for infrastructure that you're not using. You don't have to over-provision infrastructure. You're only really using what you need. So what are the benefits of Autoscale then? Well, first and foremost, it allows you to deliver the best experience to your customers. You're never going to have to be worried about being successful. As you need more infrastructure because you are experiencing high load scenarios, you will again have the ability to dynamically add infrastructure when it's needed, so that your user experience never gets compromised. Your users will never have a scenario where your site is slow or you experience downtime. A second benefit is also that it will allow you to save money, because Autoscale not only allows you to add infrastructure when it's required, but it also allows you to remove infrastructure when it's not needed anymore. So you don't have to over-provision anymore. You don't have to have infrastructure that's online and that's underutilized or not being used at all anymore. And finally, these two just allows you to have peace of mind. You don't have to worry about how your system is going to be able to handle or react to unexpected spikes in traffic. You don't have to worry about what's going to happen at 2 o'clock in the morning if something unexpected occurs. You can be safe in the knowledge that you have a system that will dynamically grow and shrink based on your user load, so that you always know you'll be able to handle these unexpected events that occur. So here's a graph that sort of illustrates the concept of what I mean. If you look at the yellow line is your demand, your user load, right? And you can see that it fluctuates. It goes up and down based on seasonality or maybe time of day, or you may do a sale or anything along those lines, right? So we all know that user load isn't a constant thing. It goes up and down. If they look at the green line, you'll see that the green line is how we have to traditionally provision capacity. If you see that your green line is constant, and if you then see that your green line goes below the yellow line at the start, you need to phone your hosting provider, or you need to go out and buy some more servers, and then you add capacity, right? Then you add a certain amount of capacity, and then that capacity stays constant until you add some more capacity later on. Now, what we tend to do then in those scenarios, because it takes us such a long time to add this capacity, or we need to add the capacity manually ourselves, we tend to over-provision. So that's what you see in the main section there is you have a period where the green line is above the yellow line, so you have more capacity than what you actually need. So you are wasting resource and you are wasting money, but you have to do that because you need to make sure that if you have unexpected spikes in your traffic, your infrastructure will be able to handle the load that it's being subjected to. And if we move a little bit further along the curve, then you're in what's arguably a more dangerous situation for you. If your load then all of a sudden spikes, you can see that you will have scenarios where you are under capacity, and that's when you suffer downtime or you suffer site slowness. Users go to competitors, those sort of scenarios, because you weren't able to respond quickly enough to the changes in the user load that's occurring. But if we then look at the blue line, you can see that really gives us this concept of capacity closer to demand. With techniques like Autoscale, you can get your blue line, which is your cloud capacity, much closer to your yellow line, which means that your infrastructure capacity can now follow your user load or your user demand a lot closer, which means that you're not wasting money on infrastructure when it's not needed, but you can also add infrastructure when it is required, so that you never have the scenario where, your user load is more than what your infrastructure can handle, and then you suffer downtime and suffer website slowness. And that really allows you to never be afraid of success, right? You never have to be in a scenario where you're worried of what's going to happen if you get really successful. If you go on Oprah or anything like that, and all of a sudden you have a massive spike in traffic, you know that your system will be able to handle the load because you can dynamically add infrastructure when it's required. So a little bit around the requirements for Autoscale. I talk to a lot of customers who are very keen around implementing Autoscale, and one of the first things they ask me always is, right, so how do I set up Autoscale? Why, is it difficult to set up Autoscale? And as you guys will see a little bit later on in the demo, Autoscale itself is actually not that difficult to set up. What's a lot more difficult to set up is the requirements, the prerequisites, if you will, in order for Autoscale to be implemented in your environment. The first one of those is your application needs to be deployed in an automated fashion. Right? You need to automate your app deployment. If you look at this example we had before, where we build these additional web servers, as those web servers come online, they must be able to accept work. They must have the code and all the libraries and everything installed so that they can accept work completely unattended and automated. There's no point in having an Autoscale system if, as these web servers come online, you have to then still manually go in and configure some things. So that's very important, right? That's the first thing that you have to have, is you need to be able to deploy your new infrastructure in a completely automated way so that it's ready to accept the work. The second thing that you need to do is you need to automate your monitoring deployment. That kind of ties into the automated application deployment, but I've separated that out because it's of particular importance, and it's something that people don't always consider. Going back to the example again, these new web servers we are creating, as they come online, they also need to register themselves with your monitoring system. And the reason that is important is you want them to also be able to trigger further Autoscale events if they start taking strain. There's no point in building these servers and then as they start to struggle, there's no way for them to notify your Autoscale system that new infrastructure or more additional infrastructure is needed. So that's why it's also very important that these machines, or the additional infrastructure you create as it comes online, it needs to be hooked into your monitoring system so they can trigger further scaling events. And then the last very important component is a work distribution mechanism. Right. So again, if we look at our example, it's the load balancer. Now, for the vast majority of cases, you will have this already, right? Most people these days have load balancers that sit in front of their web tier that distribute work, but that may not always be the case. You may have tiers in your application components that aren't web servers that you want to scale. You need a way in order to scale that tier horizontally and distribute work amongst those nodes, so that as new nodes come online, you have a way to actually send work to them. Again, in our example, we've used a load balancer. Another common way of doing that is a message queue, so that as these machines come online, they know where the message queue is, so they can then just also pull messages or pull work out of your message queue. But those three things are very important, and they are your prerequisites for Autoscale to work. Right? You have to automate your application deployment. You have to automate your monitoring deployment as well, and you need to have a work distribution mechanism so that you can integrate the new infrastructure that comes online with your system and they can actually accept work. A little bit about some of the common Autoscale elements that you will see when you look at different providers. The first concept is the Autoscale group or the scaling array. What this is, it's really just the mechanism where you define the instance that's going to shrink and grow. So you will give it an image and say, use this image, use this base image to build the new service that I want, build this flavor or this size of server. But also what it will define is a minimum and a maximum number of instances. This is important because you would want to have a minimum number of instances So you know that your usual load will always be able to be served. You also may have some redundancy requirements. So you, for instance, would say, I want a minimum of 2 servers always online, regardless of the load that is currently on the system for redundancy. The maximum number of instances is also very important because you do not want your autoscale array to spiral out of control. The last thing you want is to come in the morning and see you've got 1,000 servers that has been created because your autoscale parameters weren't tweaked correctly. So that's why the maximum is important. It's just to set that upper limit to keep your costs in check so that your costs don't spiral out of control. The next concept that we have that you'll see quite often is called a cooldown period. Now, simply put, the cooldown period is just the amount of time that Autoscale will sort of wait for new infrastructure that has come online to actually take effect on the overall load of the system. And the cooldown period is important because you don't want what we call scaling collisions. You don't want a scaling event to be triggered, and then before that infrastructure has actually had time to get into the system and start taking load and start improving your load scenario to then trigger another autoscale event, because then you just keep on triggering autoscale events before the infrastructure has actually had time to have an effect on what's occurring. So then you are very quickly going to get into a scenario where you over-provision. What the cooldown period allows you to do is you set it in a couple of minutes and you say, once one scaling event has occurred and I'm building new infrastructure, wait for 5 minutes or however long you define for this infrastructure to come online, actually start taking work, have an effect on my system, and let's then see where things are. If we then need to trigger further scaling events, then we can do that in the confidence that we actually need additional infrastructure to be able to handle the load. And it's going to be a little bit of trial and error, making sure that you set the cooldown period correctly. It will largely depend on how long it takes for your infrastructure to come online and actually accept work. And how many machines you want to build will again, be dependent on what you expect, these spikes in traffic is going to be for you. You want to build 1 server at a time? Do you want to build 5 servers at a time? That's something that you kind of have to be looked at on a case-by-case basis to see what works best in your specific scenario. The next concept that will exist, quite commonly in autoscale environments is scaling policies. So these scaling policies are these are the rules that then tell your autoscale system when and how it needs to act. There's 2 elements. There's triggers and scaling rules. Trigger is the mechanism that decides, okay, we now have to scale, whether that be up or down. Commonly you see 2 types. The one that's scheduled, which is what we talked about earlier. If you know that weekends is always a busy time for you, or the end of the month is always a busy time for you. What the scheduled trigger allows you to do is to say, I want you to build infrastructure for me at a specific point in time because I know or I expect that I'm going to have high usage, and then you can break the infrastructure down at a later date. So again, start Friday morning 4 a.m. build me 5 extra servers because I know the weekend is busy, and then Monday morning 4 a.m. break those 4 servers down because I know the week is a lot more quiet. The next type of trigger is an event trigger. And this gets a little bit more exciting and a little bit more useful for particular scenarios. And this is also what customers really ask me about, is how do I get triggers that are event-based. So these can be any events that you can define. Typically, it will link into a monitoring system, so you would look at monitoring events, and this can be any monitoring event that you can define in your monitoring system. It can be, resource events like memory, CPU, network, but you can also get as sophisticated as looking at, say, threads in an application or things like that, or transaction success rate. Anything that you can measure in your application environment and represent or call up as a monitoring event or a monitoring alert, your autoscale system will then be able to pick that up and then use that as a trigger to initiate a scaling scenario. The last element is a scaling rule, and that simply just defines whether you're scaling up or scaling down and by how many instances. So those are the common elements that you'll find when you look at Autoscale. Be that at Rackspace or other providers. You'll have your Autoscale group, which defines some general properties, and then you'll have your scaling policies, which define the specific rules on what to scale, or when to scale, and by how much, and up or down. So that's a little bit about things in general. What I want to talk about now is how you would set this up on the Rackspace public cloud, and this is also what the demo is going to showcase that I'm going to show to you in a minute. Your very first step, what you'll have to do in order to get Autoscale going, is you have to prepare your server image. So in the demo that I'm going to show you, I've done a couple of things. I've created an image, and I've installed the Rackspace Cloud Monitoring Agent, and I've also installed the Rackspace Cloud Monitoring command line tool. The monitoring agent, of course, is used so that we can monitor what happens on the server, and then also send those monitoring events up to the Autoscale system when they occur. When the alarms occur, it'll send it up to the Autoscale system. The command line tool is installed because as new instances are created from this image, we want those instances to register itself with the monitoring system, and we use the command line tool to do that. There's a little script that runs during server install time, or server creation time, that registers itself with the monitoring system and says, hey, I want to register myself with a CPU monitor, so that the monitoring system knows it needs to monitor this machine for CPU, and that when there's a CPU condition, the alarm will trigger. And the last item here is that automated monitoring deployment that I was talking about. That is some things that I've created. It lives on my GitHub repository, which I will share with you guys in the follow-up email that Eric will send out to you guys. So there's some practical scripts in there that you guys can download and have a look at and use to automate these installations, to just make it a little bit easier for you guys. So that's the first step, is prepare your image. You're going to have to put your application code on there and make sure that your application code and content is also ready to go. But in addition to that, those three things: the monitoring agent, the CLI tool, and also the automated monitoring deployment. The second step is to configure your Autoscale group. What you would want to do is create a cloud load balancer, of course, to be your traffic distribution mechanism. And then just set up your Autoscale group. Again, you'll see that setting up the Autoscale group is actually the simple part. The hard part is preparing your server images so that as they come online, they'll integrate properly into your environment. Setting up the Autoscale group is not that difficult to do. So that's the second step. And then the last step would be to set up your cloud monitoring to notify your Autoscale group. There's two concepts here that you'll need to be familiar with, when you're looking specifically at the Rackspace public cloud, and that is the monitoring notifications and notification plans. Notification is basically just an endpoint for a monitoring alarm. So what we will do is we set up the monitoring to do two things. The first one is to interface with Autoscale, and you'll see how we do that. And the second one is to send an email notification so that you can be alerted when the scaling events occur. And a notification plan is just the structure that wraps those two together. So that is something that you need to be familiar with if you want to set this up yourself. But again, the email that we'll send out to you guys will have step-by-step instructions on how to do this and go into them in a lot more detail. I'm not going to cover this off in detail now because we want to focus on the Autoscale bit. And that is what you need in order to be able to set up Autoscale at Rackspace. So we are going to now move on to a demo. I have a recorded demo that I will show you, and I'll walk you guys through the steps, what we're doing in order to actually practically set this up. So you can see here we start with the Rackspace control panel. And the first thing that I want to show you is the server that I've used to create my base image from. You can see that I've called it Autoscale Webmaster HKG. And that is a server that I have logged onto, and I've installed those monitoring components that I referred to earlier, the monitoring agent, the command line tool, and also the automatic deployment script that as the server comes online, it will deploy the monitoring agent for you. So you can see here we've gone into the server, just click on it, and you can see here there's one image that exists for the server, which I've created, and I've also called the image Autoscale Webmaster HKG, and you'll see that this is the image that we are going to use for Autoscale, we're going to tell Autoscale to use this image as our base deployment or our deployment image for when we want to do Autoscale. And this is really going to be the bulk of your work when you want to set up Autoscale. It's again making sure that you automate that application deployment of yours so that as Autoscale builds new instances of this base image that you've created, that your application deployment actually happens correctly, and that these new instances you create will integrate into your environment correctly, right? So if they're web beds, you need to have your application code on there to make sure that it works correctly. So once you've created your image and you're confident that it works, the next thing to do is to go in and create a load balancer. So we'll just go through the steps to create a load balancer. It's very easy to create a load balancer. We're going to create it and just give it a name. And for the purposes of this demo, we're just going to keep the rest of the parameters as the defaults. We obviously want it accessible over the public internet. The protocol will just be HTTP on port 80. We'll leave the algorithm as least connections. But it's important to note that we're not adding any nodes into our load balancer at this stage. We're going to go ahead and create the load balancer. We're not creating any nodes because that's what the Autoscale system will do. Again, you will see that what we do is we will provide the Autoscale system with the name of the load balancer so that it's aware that this is the load balancer we want to use, and Autoscale will automatically add nodes to the load balancer as they get created. So the load balancer is created now. We can go back to servers and into the Autoscale system. So this is where we're actually now going to define the Autoscale parameters. So you can see here we don't have any groups yet, so we're going to go in and we're going to create our Autoscale group. And we need to set some properties, right? So we're going to here set the name for our group. We're going to use the region as Hong Kong, and we're going to set a cooldown. So for this, I'm going to set a cooldown of 1 minute. Again, that's just for the purposes of this demo, so that we don't have to wait for a long time for new scaling events to occur. But again, this is something that you will have to look at, and every individual environment will be different. And again, it will largely depend on how long it takes your applications to build these new instances, right? How complex is your application deployment process? Do you just build from an image, or do you have some post-deployment configuration that has to happen? That will largely depend on your cooldown, or that will largely determine what your cooldown period needs to be. So the next thing that we'll set as well is the minimum and maximum servers. And you'll see what we'll do is for minimum servers at this stage, we are setting it to 0. Because we don't want the Autoscale system to build any servers for us yet. We need to first create the scaling group, and then once we've done that, there's some monitoring configuration we have to do before we can create our first server. We'll set the maximum at 5. For you, it'll depend on what you want to set that to. And the next thing we do is now you can see we're going to pick the image that we've created before, the Autoscale webmaster image. And we're going to set that as our deployment image. So this is where you specify to Autoscale what is it that you want it to build. So here we say use this image because it already has all the prerequisites that we need installed. The next thing we have to do is we have to select the flavor. Again, this will depend on what size you want your infrastructure to be. I'm just going to pick a 1 gig performance cloud server. We will leave the networks as default public net and service net, but if you do use cloud networks, then this is where you can define additional networks if you want these servers to be added or included into additional networks when they come online. Then we also, of course, have to pick our load balancer. You can see there is our load balancer Autoscale demo LB HKG that we created earlier, and that's where you specify to Autoscale that as these new instances come online, you want them to be added to that load balancer. That's the properties you have to set for the Autoscale group. The next thing we're going to do is now create our scaling policies. So we create the first scaling policy, which we'll call add 1 server. So this is our scale up policy, and you can see here what we're picking is the webhook URL. And this is how we interface the monitoring system with the Autoscale system. What the webhook URL is it is just a URL that the Autoscale system creates for you that when you call it will initiate the scaling policy. So in this case it will initiate the scale up. And what you'll see we do in a moment is we configure the monitoring system to hit this URL when a CPU alarm occurs. And that's how you tie the two systems together. The monitoring system then calls this URL, which then initiates the Autoscale scale up or scale down. So this is a very important part. And that's why we pick webhook URL. The next thing we'll do is we're going to say, well, we want to scale up. Okay, here we go, we're going to scale up. And we're going to pick by one server. And again here I'm picking my cooldown period is 1 minute, but you need to decide what will best work for you. So that's all we need to do to create the scaling policy. We're going to do the same just for a scale down. Again, we pick a webhook URL, but this time we select scale down instead of scale up, and again by one server, and I'm picking the same cooldown as 1 minute. And that's it. And now we can create our scaling group. So once the scaling group is created, there's one more thing we have to do in this Autoscale system, and that is again with the policies. You can see that under the top, the webhook is now changed to a link, because we now need to go into each one of these and actually create the webhook, which will generate the URL for us. So we're going to go in here and just create the webhook, give it a name, and there's the URL. What you need to do is I'm copying this URL out because I need to specify this URL to the monitoring system when I create those notification plans. So I'm just copying the URL out and do the same for the remove one server. So we're just going to create a webhook for it as well. We call it scale down. Clicking on Save the Webhook to generate the URL for us, and we're going to copy that out. And you'll see what these URLs look like. It's just a very long random URL string that gets created that when you hit it, it will initiate a scaling policy. And that's all the configuration you have to do to set up Autoscale. You can see that it's actually not that difficult. It's fairly simple. There's not a lot to it. The most important bit, as I said again, is creating that server image of yours that when you deploy it, it will instantiate a server correctly and go from there, and it will integrate properly into your environment. One of the things we have to do now, once you've created your Autoscale group, we need to set up the monitoring notifications and notification plans. That at the moment is API only. So what we're going to do now is just jump onto the command line and run a script to configure these for us. And again, this script will be available to you guys, which I've created. It's called racksmonsetup.sh. And you can see here, we need to specify some options. The first one is the region for Hong Kong. The next one is the email address that you want to be notified on when these events occur, and I'm just using my own personal email address. And then we need to specify these two webhooks. So you'll see that we provide the webhook scale up, which is that long URL that we copied out a little bit earlier, and also the webhook scale down. And when you run this, it will interface, or it will hook into the monitoring system and create these notifications for you. It will create the email and the scale up and scale down notifications and create a notification plan, which you can then use with your monitoring. And you'll see how that works in a minute. So when the script runs, when it finishes, you'll see that it creates a notification plan, and the notification plan's name, which is plan, email, and webhook AS for Autoscale Web HKG. Take a note of that name because you'll see us use that a little bit later. And that's all we have to do, luckily, on the command line to set up the monitoring, set up these notifications in the notification plan, and then we are ready to configure our monitoring. So what you'll see here, we'll go back to the Autoscale group, and we are now ready to configure our first server. So we changed the min service to 1, and you'll see that this server is starting up. We'll just wait for the server to build, and then we'll have a look at it. So the server is built. By the way, I've sped up some of these build processes just so that we don't sit waiting just for the interest of transparency. But anyway, here we can see, if we look at the server now, you can see that it's been deployed using our image, Autoscale Webmaster HKG. It's got a flavor of 1 gig. And you can also see that the monitoring agent has been installed. You can see there, you can see the RAM and CPU and disk performance. You can see that the monitoring agent has been installed on it. So that is what gets automatically done to the server when it gets instantiated, because we've prepared our base image with the monitoring system already installed. So when the new server comes online, it already has the monitoring agent enabled. You can also see here that it comes online with a CPU monitoring check. And with a CPU usage alarm, and there you can see our alarm. We'll just have a quick look at the criteria for the alarm. The criteria here says if the usage is above 95%, then generate a critical alarm. If it's above 90%, then create a warning. Otherwise, return OK. So what this basically says is, if the CPU goes over 95%, create a critical alarm, and that alarm will then trigger our autoscale to scale more servers. So you can see here the notification plan that we use is the one that we created just a second ago from the command line, plan, email, and webhook AS web HKG. And this is again how the two interface with each other. You create a monitoring plan which will hit the webhooks when the scaling events occur, and then you tell your monitoring alarms to use that notification plan as the set of actions it has to perform when a monitoring event occurs. So now we're ready to initiate some scaling. So we'll log onto this machine, just getting its IP address. We hop onto the command line to log onto the server. And then what you'll see is we're going to induce a CPU condition on it. We're just going to run a little command using DD that will induce some high CPU usage, and that will then hopefully trigger some further scaling events for us. So there we run our DD command. You can see here also just it is the right server. I'm not cheating. If you look at the host name. And now we just have to wait for a little bit for the CPU condition to occur. So you can see I received the email from the monitoring system that says my server is now experiencing a critical CPU condition. And if you look at the portal, you can also see that the portal matches. It says we have a critical CPU condition. And if we look at our Autoscale group, you can see that the status has changed to scaling. And if we scroll down, we'll see that we're building a new server. And that's basically how it works. We now have a system where, based on a CPU monitoring alert that we've generated, the Autoscale system dynamically builds more servers for us. And that's basically how Autoscale works. So what we'll do now as well, I think in this demo, is log back onto the server. Well, we're going to look at the load balancers first, sorry, just to show you how the load balancers work. So if you look at the load balancer, you can see there's a load balancer, and if you look at the load balancer, you can see that both of our Autoscale instances have automatically been added to our load balancer because we specified to our Autoscale group that this is the load balancer we want to use. So you don't have to worry about adding your servers dynamically to the load balancer. Autoscale takes care of that for you. And that's pretty much how it works. What we'll do is I'll also just show you how it works when we now cease the CPU condition. So I'm just going to kill that DD command to terminate the CPU, the high CPU alert. And we're going to have a quick look at the server. To look at the CPU condition. You can see that the CPU condition is now not in a critical state anymore. And we've received our email saying that the CPU usage is now okay. And if we then go back to our Autoscale environment and we look at our Autoscale group, you will see that it's already removed one server for us because the high CPU condition does not exist anymore. And that's pretty much it. That's how it works. So again, we have a system now where we can have, sorry, there's a question here that someone's asked. Let me just have a look at it. What is the question? Well, okay, so Drexel is asking what would we need to change in our application in order to make it scalable? That depends on the nature of your application. If you look at traditional web architectures, then the web server tier is usually fairly easy to scale because the web tier doesn't store any data in the sense that a database does. So the web server can very easily, the web server tier can very easily be scaled horizontally. So you can very easily add additional servers with a load balancer in front of it, and you shouldn't have to do very much to your application to make it scalable. Things to keep in mind is if you, for instance, have any need to synchronize content between the servers. So if you, for instance, have users that upload content, so for instance, users that upload images or something along those lines, what you will need to do is, in that case, as soon as you then have two web servers, you need to find a way to synchronize that content between the two, or figure out some other strategy to make sure that both of your servers have access to that data. But user uploaded content is usually the thing that you've got to consider the most when you want to scale your web tier. Database tiers are a lot harder to scale because you have data consistency to keep in mind, right? There's not that many database applications out there that you can just scale active-active, right? Which will allow you to read and write to more than one database instance at the same time and still keep your data, safe and maintain data integrity. What you can do on your database tier, for instance, is have one write node and multiple read nodes. But in an autoscale environment there, it can get quite difficult because if you want to create new instances, you first have to load all your database data onto that new instance, and that can take quite a long time. So really for autoscale, where we see the best applications is in web and application tiers where you don't have this data consistency burden to consider, so you can very quickly and easily scale your web tiers up. I hope that answers your question. Okay, I think some final thoughts from me before we can go into questions is please email me if you guys have any further questions or thoughts or need any help with any of this stuff. It's gerhard.pretorius@rackspace.com. We'll also, again, send this out to all of you guys that joined the webinar in an email, so you have that handy. And I'll talk about the Developer Plus in a second before we sign off. I just kind of want to put it open now to any other questions that you guys may have. So Drexel, has that answered your question? Okay, so you've asked the same question again. What would we need to change in our application in order to make it scalable? Did the previous answer I give you answer that question, or are there any more specifics that you want to know? Okay, so Vishal, you've asked, do you have spot-on instances with Autoscale facility? Can you explain a little bit more what you mean about spot-on instances? So do you mean AWS spot instances? No, at the moment on the Rackspace cloud we do not. We do not provide spot instances. We only have one tier of instance. We've got different flavors that have a different price associated with it. So for us, flavors would be the size of the server, so a 1 gig or a 2 gig or a 4 gig RAM server, but we don't have spot instances at the moment. So Drexel is asking, would Autoscale affect how you manage sessions? So Autoscale itself wouldn't really have any effect on how you manage sessions. Your consideration on how you manage sessions would simply be what you do, on a specific tier if you have more than one node performing that function. So that's not really anything to do with Autoscale. That is more just in general a question of how does your application scale horizontally. But in order for Autoscale to be of value to you, you need to make sure that this tier that you're thinking of autoscaling can scale horizontally. So from that perspective, it's more a case of does horizontal scaling affect how you manage sessions? And yes, it does, absolutely. Typically, what people do is they would keep session management local to a specific instance, and you would configure the load balancer in what we call sticky sessions. So what that will do is the load balancer will, once a user has initiated a session to say web server 1, and you've got 4 web servers in your web server tier, the same user will keep on going back to web server 1. So you maintain session integrity. That's a very common technique that we use in the industry to ensure that you don't have to think about sharing sessions, or synchronizing sessions between all your nodes. If you want to, it can get quite complicated, but you can share sessions between your servers, which then means that whichever web server, whichever server in that tier you interface with, the session information will be available to it, and then the load balancer can pick any server. But I would say if you're just starting out with these sort of scaling questions, definitely don't worry about trying to share sessions between nodes. Configure your load balancer with what we call session persistence or sticky sessions, so that your users will always go to the same node. And then from that perspective, from a session point of view, you handle it the same whether it is one server or however many servers, because again a user will pretty much just interface with one node all the time. Okay, I'm just looking to see if there's any other customers. So Asiri is asking, what would be the best way to deploy application updates in an autoscale environment? So the best way to do that really is, it depends on how you prepare that base image of yours, right? There's 2 ways you can do that really. The first one is you can take a server, configure application on it, install everything that needs to be installed on it, and then take an image, so that when you deploy a new instance of that image, all of that configuration is already available to you. In that scenario, what you will have to do is you will have to periodically update that base image of yours. You will have to periodically, have that master server of yours, create, you have to take that base image of yours, create a server from it, update your code, update the, do operating system updates and that kind of thing, and then save an image of it again. And you can see that that can get a little bit quite cumbersome. Every time you want to make a code update, you have to first log onto a server, make the update there, and then save an image. So that's why what a lot of people have started to do is what we call post-deployment configuration. And there's things like Chef or Puppet, or if it's not that complicated, something called Cloud Init that you can use. And what that would do is, the concept there is you basically use a base image from your provider. So you don't do anything special to that image. You just deploy onto a base image, and you dynamically install all your content. You pull your code from GitHub. You run your yum install to install all your applications and that kind of thing onto the server every time you create that instance. And then that way, all you have to do to make sure you have the latest version of code on these servers is keep your GitHub repository up to date, because every time a server gets created, it will pull the latest code version of GitHub. And every time a server gets created, it will install the latest version of Apache with all the security updates installed and the latest version of PHP. That can create another issue for you if your application is quite sensitive to updates. You can have scenarios where a server will come online and it will install the latest version of something, and then your application code won't work. So you've got to be mindful of that. But that's really the two scenarios, right? So to recap, the first one is you can create an image, which you can call a gold master image that you use to deploy new servers from, but you will then periodically have to go in and keep that image updated. Or you can do post-deployment configuration where you sort of dynamically install what needs to get installed every time a server gets instantiated. But you need to keep in mind that you can run into software compatibility issues. I'm trying to see if there's any more questions. So Siri, you're asking, will bringing an application down for deployment trigger a new instance? It depends on how you configure it. I would say if you want to take your entire application down for deployment, you can pause your autoscale. Right? You can either go in and just press pause on the autoscale, or you can make your cooldown period something ridiculous, which then means that nothing will be created. And in that way, you can then ensure that Autoscale doesn't start to create or destroy things when you're doing a deployment. But in general, the way that Autoscale gets configured with its triggers is one of two things, right? It's a schedule. So if you want to do your deployment, just don't do it when the schedule is going to occur or based on some event. So if you're taking your entire application down to do some maintenance on it or do a deployment, chances are you're not going to be triggering any monitoring events, so Autoscale won't trigger. So in most scenarios you'll be safe, but again, it depends on how you configure Autoscale on whether you can inadvertently trigger scaling scenarios or scaling events if you do deployments. Okay, I think that's answered all the questions. If no one else has any more questions, we can end the session. I'm just going to wait a couple more seconds. Well, okay, so what I'll do is I'll talk about the developer program for you guys, Developer Plus, while we wait for more questions. So Developer Plus is a new thing we started quite recently. And you can access it by going to developer.rackspace.com. And what Developer Plus is really is Rackspace is giving away free infrastructure for you guys. For you developers out there that want to start, using Rackspace, see what it's all about, see if you can use it for future projects. We can give you some infrastructure. So we'll give you a load balancer, a server, some block storage, some cloud files, and some free bandwidth. And that's free for a year. And then after a year, you can then decide whether you want to move up to one of our paid tiers or whether you want to discontinue your service. So I invite you all to go and have a look at developer.rackspace.com and sign up and start using it because it's free. And that will give you a way, like a very good way to start using our infrastructure and get used to it and see if it will fit your needs. Something else I want to mention as well, we're not seeing any more questions, so I think we can end this. is we're going to be sending you guys a survey for some feedback on the webinar. We would greatly appreciate it if you guys would fill that in and send it back to us so we can get some feedback from you on how this went. And that'll also be an opportunity for you to let us know if there's any other webinar or other topics you want us to discuss in webinars. We value your feedback. The more vocal you guys are and the more you ask for things, the better we're able to provide you guys with what you want. So please, fill in that survey and get it back to us so we can get some feedback from you guys. And I think that's it. Just lastly from me, thank you very much, guys, for joining. It's always exciting for me to share new things with you guys, so thank you very much for taking the time. And again, all of the stuff we discussed here today, all this demo, I know I breezed through it quite quickly. All of the stuff will be available in the email we're going to send to you guys, and the recording will be made available to you guys as well. So that's it from me. Until next time, thank you very much, guys, and enjoy the rest of your day.